Today we're going to be examining the flow around various shapes. So this would be like if you have wind blowing into these shapes, how will the air flow around the shapes? First, we're going to look at a square cylinder with the flat side facing the wind and a square cylinder with the corner facing the wind. Next, we're going to look at a circular cylinder. Now, the orientation of this doesn't matter because it's a circle, so it's going to be the same no matter what. And we're just going to see how the wind flows around this object compared to the square. Finally, we're going to look at the airfoil. An airfoil is basically like a plane wing. And we're going to see how the angle of the plane wing creates the force that allows a plane to fly. And we're going to see when this angle becomes too great. Now, to examine flow, we're going to look at something called drag force. Basically, when the wind blows in an object, it's going to create a drag force on the object itself. Now, the equation looks complicated, but for now, we're only going to look at the drag coefficient. Basically, the higher this coefficient is, the more force the object will experience when the wind or whatever fluid is blowing on it. We're going to look at a couple of video examples of what the flow looks like around these objects. As you look at these, I want you to see which one you think has the highest drag coefficient. Now, a higher drag coefficient means that it's less aerodynamic, or it's going to experience more force due to the air or fluid rushing against it. So just look at the examples and see which one you think will have the highest, and we'll see the answers. As you can see, the square at 0 degrees had the highest drag coefficient, which makes sense since that flow looked the most turbulent compared to the circle and the square at a 45-degree or diagonal orientation. Now, how exactly would we use this in the real world? Well, we can look at wind against various objects, like a flagpole, for example, which is a circular cylinder, right? When the wind blows against it, it's going to have a certain drag force against it. And when we see this force, we want to see if the flagpole is still stable. Now, another example is a building. A building is typically the square cylinder shape, right? When the wind blows at the face, it's going to experience more force than if it blows against the corner, as we saw earlier, since the drag coefficient is higher at 0 degrees than 45 degrees. So these are a couple interesting examples for you to think about and how you actually utilize this in the real world. Finally, we're going to look at the airfoil and how it creates the lift force that lets an airplane fly. Now, when the airfoil is oriented at a certain angle, it creates a pressure difference between the top and the bottom of the wing. Now, this is what creates this lift force that allows the plane to fly. Now, when we increase this angle too high, this pressure difference no longer occurs. Now, this means that there's no longer a lift force, so the plane will no longer be able to keep itself in the sky. This is why planes can't really descend that quickly. Otherwise, the angle of the wing will be too high and the plane will stall.